Critical numbers. Our objective is to use the derivative to find critical numbers of a function. A critical number of a function f is a number c in the domain of f. I highlight that because that's important. That means critical numbers are x values. So a number c in the domain of f for which either f prime of c equals 0 or f prime of c does not exist. I like to think of critical numbers as where something critical happens. Again, where it happens. It's an x value, which means it's a location of something critical happening. Remember that we often have something critical happening when the derivative equals 0 or the derivative doesn't exist, because that's where we often find local maxes or mins. Not necessarily that just because these things are true means there will be a local max or min, but there might be. Anyway, it means some place where something critical is happening, and that's going to be where the derivative equals 0 or the derivative does not exist. Let's find the critical numbers of this function. So we'll start by taking the derivative, although I notice that this function has a denominator, and the denominator will equal 0 when x equals 0. So x can't equal 0. 0 is not in the domain of the function. Now, before I take the derivative, I think this would be easier to rewrite this function so there is no denominator. 9x to the negative 1 minus 27x to the negative 3. Now I'll take the derivative, f prime of x equals negative 9x to the negative 2 plus 81x to the negative 4. That translates into negative 9 over x squared plus 81 over x to the 4th. And it'll be easier to do things if I find a common denominator here. So multiply this by x squared over x squared, and I get negative 9x squared plus 81 all over x to the 4th. Now I remember that my critical numbers are where the derivative equals 0 or where the derivative doesn't exist. Let's start with where the derivative, f prime of x, equals 0. So I take my derivative, negative 9x squared plus 81 over x to the 4th, set it equal to 0. Now, this is going to equal 0 when the numerator is 0. Or I could think multiply both sides by x to the 4th. So it's negative 9x squared plus 81 equals 0. And solving for x, 9x squared equals 81, x squared equals 9, so x equals 3 or negative 3. Both of these x values are in the domain of the function, so both of these are critical numbers. How about the second part of critical numbers, where f prime of x does not exist? So I notice that f prime of x has a denominator, therefore the derivative doesn't exist where the denominator equals 0, and that's where x equals 0. However, this is not a critical number because, as we pointed out earlier, x equals 0 is not in the domain of the function. So let's make a note about that. This is not a critical number because f of 0 does not exist. 0 is not in the domain of the function. So my only critical numbers are x equals 3 and negative 3. Let's find the critical numbers of h of x equals the absolute value of x minus 2. Now, we can't take the derivative while we have the absolute value there. So let's rewrite what this really means as a piecewise function. This means x minus 2 for all x values greater than 2, negative of x minus 2 for all x values less than 2, and 0 for all x values equal to 2. Remember, we're looking at where the inside equals 0, and that's how it gives us x equals 2 as that break apart point. So now let's take the derivative h prime of x of each of these pieces. The derivative of x minus 2 is 1, so the derivative is 1 for x greater than 2. The derivative of the second piece will be negative 1, so that's for x less than 2. And the derivative at x equals 2, well, you can't have a derivative at one point. So the derivative does not exist when x equals 2. Now, notice the derivative never equals 0, but the derivative does not exist at x equals 2. So our critical number, we have only one, is x equals 2. And that's because h prime of 2 does not exist. This problem is calculator active. For f prime of x equal to cosine squared x over x minus 1/5, how many critical values does f have on the interval 0 to 10? So notice a couple things. We want to know how many critical values there are on the graph of f. Now we were not given the graph of f, we were given the function f prime of x. Also, we're not asked to find what the critical values are, we're just asked how many critical values there are. Let's go to our calculator and let's plug in the f prime of x function into y equals. In my calculator, here's the function, the derivative f prime of x plugged into y equals. I change my window to make sure that it's only showing the interval 0 to 10 so that I don't think about any other values. 0 is the x-min, 10 is the x-max, and I only need to see slightly under and over the x-axis. So I've picked values close to y equals 0, like -2 and +2. Now when I look at the graph, it shows me here it equals 0, here it equals 0, here it equals 0. This is f prime. All the places where f prime equals 0 happens 1, 2, 3 times. We weren't asked what they are, we were just asked how many. So just to take note of what we saw, I graphed f prime of x, and I saw the graph looked something like this. So I'm looking for how many times does f prime of x equal 0. Remember, this was a graph of f prime of x. It equals it once, twice, 3 times, and that's it. So I have 3 critical values. And that's it. If I were asked to find what are the critical numbers, then I could calculate those zeros and find them.